Good morning. Nomenclature Part 3 also deals with ionic compounds, but this time we are dealing with polyatomic ions. You probably have a sheet that looks like this or similar. It said common anions and cations, and at the bottom of it, it says polyatomic ions. We are going to be looking at how to write formulas and name compounds that include polyatomic ions. Notice again, all of your polyatomic ions are negative except for ammonium and hydronium. These are your only two positive polyatomic ions. So in order to have an ionic compound, you will have a metal or ammonium or hydronium. What is a polyatomic ion? Well, a polyatomic ion is a 3 or more atomed ion. And you must learn those in order to recognize them when you see them in a compound. If you were to see CO3 in a compound and did not know that this is carbonate, you might want to call this carbon trioxide. It's not carbon trioxide when it is with a metal. If there were a metal in front, such as Na2CO3, then this becomes carbonate, the ion. And Na is sodium, so the name of this would be sodium carbonate. If you don't know that CO3 is carbonate, this will be very difficult for you. Learn your ions. Once again, a metal or ammonium or hydronium will be written first, thus indicating an ionic compound. When writing formulas, the charges must balance. Subscripts are used for this purpose. We're going to do the same thing we did in the earlier examples of ionic compounds. Put the charges above the name, +2 strontium, -1 nitrate. We need 2 nitrates in order to balance out this strontium. In order to do this, we use parentheses. Now, I will acknowledge these notes are a little backwards, so let's go down and look at parentheses. Use parentheses around the polyatomic ion when more than one is needed in the formula. So in this case, nitrate, we need 2 of them. So we're going to put Sr, that's our strontium. Nitrate, I know, is NO3. How did I know it? Because I memorized it. Right here it is, NO3, and it has a -1 charge. How many do I need? I need 2. So Sr, NO3, parentheses 2. This 2 outside the parentheses means there are 2 nitrates, totaling a -2 charge to balance out the strontium with a +1. Silver is +1, sulfate is -2. How many silvers do I need? I need 2. So it is Ag2SO4. Again, how do I know sulfate is SO4? I've memorized it. Sulfate SO4. If charges are already balanced, do not crisscross. Simply write the formula or symbol for the cation and anion with no additional subscripts. Ammonium cyanide. Ammonium is +1, cyanide is -1. I'm simply going to write the formulas. Ammonium, NH4, cyanide, Cn. Do be careful that your letters are capitalized where they should be and lowercase where they should be. We've already said use parentheses around the polyatomic ion when more than one is needed. Ferric, +3, cyanate, -1. So how many cyanates do I need? I'm going to need 3. I haven't been showing the crisscrossing, but I can do that. Remember, you don't write 1. So we need 3 cyanates. Ferric is iron, so that's Fe. Cyanate is OCN, parentheses 3. Aluminum dichromate. Aluminum plus 3, dichromate negative 2. This is a very good example of crisscrossing. We need 2 aluminums to balance out the dichromate. What's dichromate's formula? Hopefully you know it. If not, look it up, Cr2O7. Now I want to point out, these subscripts are with Cr2O7. These have nothing to do with balancing the formula. These, in essence, are how dichromate spells its name. It's similar to your initials. If your initials are MB, then MB is how you spell your name. Carbonate spells its name CO3. Dichromate spells its name Cr2O7. That's its shorthand method of saying it or writing its name. So aluminum, Al, 2, dichromate is going to be in parentheses because there's more than one needed, Cr2O7 parentheses 3. Lots of times students will ask the question, for instance in this example, do I need to put those in parentheses? No, there was only one ammonium, there's only one cyanide. Another problem that students tend to have is they want to put NH in parentheses with a 4 outside. You don't do that. NH4 is ammonium. That is how it spells its name. This list of examples include all types of examples. They will include all of the different kinds of examples that we've had other than molecular compounds. It's still all ionic, but some of these may have transition metals. Let's decide where the transition metals are first because that will make it easier. They are all ionic, so I'm not going to worry about molecular ionic. I'm going to only look for transition metals. Barium is a regular metal. Lead is a transition metal. Sodium, normal metal. Iron, transition metal. Barium is a normal metal. On the right-hand side, I don't have to worry about whether it is a transition metal or not because the charge would be given to me in the name if it were, and none of these are. All of these are monatomic ions with no other charge than what they have normally. So let's look at the examples. BaSO3. If you do not recognize SO3 as sulfite, learn that SO3 is sulfite. So we simply name it. Ba is barium. SO3 is sulfite. Barium sulfite. Why don't I have to do anything with the charges? Because it's already taken care of. This is already balanced for me. I don't rebalance it when I'm naming it. Lead is Pb. I don't know which lead it is until I figure that out from the charge of the anion. ClO is hypochlorite with a -1 charge. 2 times -1 equals -2. That means this lead must have a +2 charge. So the answer is lead 2 hypochlorite or plumbus. Na2Cr2O7. Na is sodium. Cr2O7 is dichromate. Fe2O3. Transition metal, I've got to figure out what iron this is. Is there a polyatomic ion? No, there is no polyatomic ion in this at all. Oxide is -2. 3 times -2 is -6. 2 times whatever that positive is has to equal +6. What is that positive charge? It must be +3. So the name is iron 3 oxide or ferric oxide. The last naming example is a regular ionic, so we simply name these as they are. Ba is barium. PO4 is phosphate. So barium, phosphate. Please, if you do not know your polyatomic ions, learn them. It will make this so much easier for you. Let's look at the right-hand side where we're writing formulas. When you write formulas, put the charges above the name. So +2 for magnesium, phosphite is -3, ammonium +1, oxide -2, strontium +2, dichromate -2, beryllium +2, arsenate -3, aluminum +3, nitrite -1. Hopefully you've paused the video and have tried these. If not, try them now. Then come back and check yourself. Crisscross brings the 3 down, brings the 2 over. That means 3 mg's. Phosphite spells its name PO3. I need 2 of those. Ammonium is NH4. I'm going to need 2 ammoniums to balance that out, to make it +2 to balance out the -2. So I put parentheses now, 2O. Again, 2 ammoniums, 1 oxide. Strontium dichromate is balanced, so it is simply Sr, Cr2O7. Beryllium arsenate. We're going to need 3 berylliums to balance out with 2 arsenates. Be3. Arsenate is ASO4 parentheses 2. Double check. That's 3 times +2 is +6. 2 times -3 is -6. And the last example, aluminum is +3. Nitrite is -1. That means I'm going to need 3 nitrites. So Al parentheses NO2 parentheses 3. So aluminum nitrite.